So this is LÖVE Studio. It's an IDE that I made for the 2D game programming framework for Lua called LÖVE. So LÖVE Studio might seem like a strange name for an IDE, but those who are familiar with IDE naming conventions know that there is Visual Studio and Eiffel Studio. So with that in mind, maybe it's a sensible name. I've been thinking about renaming it, but who knows if I will ever do that. So this is a project that I've been working on in my free time for years, and I have posted YouTube videos about it before, but the ones that are currently online are way out of date. Every once in a while for the past few years I've been adding more and more features to this project, so I felt that it was time to post another video. So unlike previous videos, I'm going to try to iterate through all the features of LÖVE Studio rather than getting into technical details. So LÖVE Studio is a project-based IDE. When you first open it up, the first thing that you need to do is create a new project. And the new project should probably be in an empty folder. Let's just call it test project. Okay, so if you press Control-O, it brings up a menu of all of the modules in your program. And LÖVE Studio comes with a template containing all of the standard files that you would expect in a LÖVE project, plus a few extras. So if you're familiar with LÖVE, you know that a conf file lets you set the dimensions of your window. It lets you set the author and the title of your game, and all of these other technical fields that you can toggle. So that's conf. And the main file usually contains callbacks that you need to implement in order to create a game. Let's see, there's also, is there anything else? There's conf, there's a main. So all of these other things are either data structures or a class system or the globals file. This is a file that's kind of special for LÖVE Studio. Before I talk about that, I'm going to talk about the type system in LÖVE Studio. The type system enables all sorts of IDE features. Although, I guess a disadvantage to having this type system is that it's not, it kind of changes the language. People who know how to use Lua aren't necessarily going to figure out the type system right away. But there is a document explaining all of its features on the wiki for LÖVE Studio on its Bitbucket page. I'm going to show you just a few of them. So let's say that I want to make a new canvas. So you'll see that we have all of these IntelliSense call tips, and these are all enabled by the type system. So the type system will track the return type of new canvas. See here it says it returns a object of type canvas, and it will associate that with the canned variable. So if I hover over canned, it tells you what type this canned variable has. It also gives you a description of the type. So that's pretty cool. So now that it knows that canned has type canvas, if you try to index into it, it will supply you with a list of all of the methods of canned, or of canvas, that is. And of course it provides IntelliSense support for all of these methods. And there's also an interactive type checker built in. If I try to call something that's not a method, like green, for example, will see a red squiggly line show up. And if you hover the mouse over this red squiggly, it will explain what the problem is. In this case, Canvas does not have a method called green. Okay. All right, now let's try to do something exciting. Let's draw something on the screen. I guess we can draw a circle. Nice, IntelliSense tells me what all the arguments to circle are. So we've got mode, the x-coordinate, let's just say 100, y-coordinate's 100 as well, and the radius is going to be 50. Okay. And let's make the circle blue. Let's see, 0, 0, 255. 255. All right, that should work. So we press F5, and then we see this blue circle show up. Beautiful. So there's also a setting. You go to Project Settings that lets you embed the game inside the game panel. And what is the game panel? Well, I'll show you. Once you enable the setting and you press F5, now when you open the game will be embedded in this panel right here. It's one of the many panels that exists in LÖVE Studio, along with output, debug, search, error. And if you press F4, it'll close out the game panel. Okay, that's pretty cool. Let's just demonstrate some of these other panels. Like, there's an output panel. So if you want to print, hello, this is test output. Then we press F5. Open the output panel, and it'll print out the output that we printed. And this output window persists even after you close the game. And it's also searchable. You can press Control F, and let's say I want to search for, oh wait, that's not right. You can do incremental search at least. Okay. So getting back to the subject of the game panel. So right now it's just kind of a convenient way to view your game and at the same time be able to cross-reference it with your code. See, I can browse my code just as normal while the game panel is up and running. And I can also hover over identifiers and get IntelliSense support. One thing that I can't do is program. If I try to type anything in, I will get an error message. Source files cannot be changed while game is running. So when I originally started making this IDE, my idea was that the game panel would interact with the IDE. So for example, you might be able to hover over a certain identifier, and then in the game panel, the object that that identifier refers to might be highlighted, or something along those lines. But I haven't gotten around to implementing that. I'm not sure if I ever will. So that's kind of sad. But there are many other features in LÖVE Studio. All right, so let's continue with this circle program. Let's try to streamline the task of drawing a circle. So to do that, we're going to define types. At the top of every module, you can create a list of type definitions. And this is in the module header. Notice that we have this description of the main module up here. And when you press Control O, these descriptions that you see in this module open window are the ones that are contained inside the module header. So this stuff is the same as this stuff. So we can change the module description if we want. Like, let's say that we want to make it a smiley face. Now when we open up main, we see a smiley face in the description. But actually I liked this description better, so we'll keep that. So in addition to having a module description and a module header, you can also define a list of type definitions. And these type definitions can be referred to globally in your project, not just the module that they're defined in. So let's say that we want to define a circle type to kind of streamline the task of creating circles. All right, so you would say circle equals, and then you would make a record type. Record types are contained in curly braces. And can put a description up here, although I don't know how I would describe the circle type. I'm just going to say circle. Normally I would avoid creating comments that are this redundant, but this is just for example. So let's see, a circle should have a color, a radius, and a position. So let's make a type for color also. Color has red, green, blue, and alpha components. So let's just call them RGB and A. They are all numbers. Oh, let's actually make A an optional number. This means that it can either be a number or it can be nil. Okay, and we can actually add descriptions for all of these fields. So the red component of the color, 0 to 255. Let's just copy this and just reuse it for all of these. Of course, we have to change. This is going to be green. This is going to be blue. This is going to be alpha. And let's just add it. Let's just say that it is 255 by default because it is optional. Okay. Now we can continue with our circle type. Circles have a color, type color. They have an X component of type number, a Y component of type number, and finally a radius. Radius of type number. Okay, I could comment all those fields of circle, but I'm not going to. Okay, so now let's make a function that takes a circle as an argument and draws that circle. Okay, local function draw circle. Okay, and it has one argument actually, circle. And we need to annotate this argument with a type. To do that, we can just type PR tab. PR stands for param, and the snippet expands for us. So for name, we have to put a name that matches one of the arguments, in this case, circle. For type, you should be able to press tab to cycle through these different fields, but if you wait too long, you lose the opportunity. So that's probably bad. For type, we would want circle, and description, the circle to draw. Okay, so I'm going to try doing this again, but doing it the real snippet way. Circle, tab, the circle to draw. Much better. Okay, so now we've got this circle. If we index into it, we can see that it has all of the fields that we specified for the circle type. So the first thing that we need to do when drawing a circle, of course, is to set the color. And the color is going to be contained in the circle color field, although I don't want write circle color a bunch of times. So I'm just going to make a local called C that is equal to circle color. Okay, so now we have CR, CG, CB, and CA. We actually, we did comment all of these fields, so if we hover the cursor over any of these, we actually get the appropriate comment, although there is kind of a space in there that is maybe not a good thing to have. Okay. Now, I should probably cut all that white space in front of the comment away. So anyway, we've set the color, and now we are going to draw the circle. Okay, so let's make it a filled circle, and the x and y coordinates are contained in the circle object. That's actually a table, to be more precise. And then I think radius is the last one. Yes, radius. Okay. So now our circle drawing function should be complete. Let's test it out. Oops. So we would have to call draw circle inside our draw function. And we pass it a circle. We're just going to pass it a literal table that conforms to the circle type. So we would have to give it a color field. Red is going to be, let's make it a red circle, or like a red-green circle. I don't know what color you get when you combine red and green, but we're going to find out. And let's actually exclude alpha because it's an optional parameter, and I just want to show that you can do that. But what is not optional are the x coordinates of the circle. We're going to put that at x at 200, let's put y at 100, and let's put radius at 20. It's a small red circle. Okay, let's try running. No, it's got these red squigglies. I better fix those first. So the first red squiggly is caused by the fact that I forgot to put a comma after the color field. And so is the second red squiggly, apparently. So now I should be able to run. Okay, there. Oh yeah, right, it's not a red circle, it's a yellow circle. So when you combine red and green, you get yellow. Who knew? Okay, one cool feature of LÖVE Studio is that it has bidirectional type checking. So if I had given any of these fields a value of the wrong type, like let's say that I gave blue a type or a value that is a string, this is not a number. What would happen? Well, what would happen is that a red squiggly would appear beneath the this is not a number string. Actual type string does not match expected type number. So that's pretty neat. What would happen if we excluded the B field? Well, let's see. Would something happen? I'm pretty sure it would. Okay. Yeah, I had to move the caret down there, but constructor missing field B of type number. So anyway, the point is the error messages that are generated are at an appropriate granularity. Rather than putting a red squiggly over the entire table that is being passed into draw circle, it only puts a red squiggly under the portion of the table that doesn't conform to the expected type. So we have this circle type as well as an operation that can be performed on it. What if we want to bundle the operations that can be performed on circles with the circle type? we can do that by making a class. To make a new class, you first press Control N. This is actually generally just a way to make a new module. You can make classic modules, that's just a built-in Lua module. You can make empty modules, or you can make basic class system modules. Basic class system is a Lua class system that I made with the intention of being statically typed in LÖVE Studio. I actually have a plugin interface where hypothetically you could make new class systems which are also compatible with LÖVE Studio's static type checker. But right now the only class system you can use is basic class system. So we want to make a new basic class system class called circle. And then if we wanted to inherit from a parent, we could type the name of the parent in right there. And then we can also add a description. Let's see, round shape that encompasses all points within a distance. Okay. So it creates this template for us with a constructor. We need to add some constructor arguments. So we need color, x, y, radius, and then we can use snippets to specify the types of these constructor arguments. Okay. And then we need to create data members that stores each of the fields of a circle. So they correspond directly to the constructor arguments. To create a data member, you just type self.dataMemberName equals value. So that is our circle constructor. Now we need to give it a method for drawing circles. The code should basically be the same as the draw circle function that we previously wrote. Let's just copy this. But of course, there's no variable called circle. It would more be referred to as self in this context. So just replace all occurrences of circle with self. And now our function for drawing circles should be complete. Okay, so now we want to instantiate the circle class. First, let's get rid of this old circle stuff. Before we can instantiate the circle class, we need to require the circle module into our main module. To do that, just press Control R and then type circle and press enter. And see, it automatically added this line, local circle equals require circle. Now we need to call this circle module to instantiate a new instance of the circle class. So let's just call it circle1. And the color is going to be is equal to 0, blue is equal to 100. The radius, let's just give it a radius. Oh wait, that's the color. We need x and y. 400, 300, 200. Okay. Now in the draw function, all drawing should be done in the LÖVE's draw callback. We will call circle1 draw. Now if we press F5, there is an error. There's something called bleep bloop. I have no idea where that came from. All right. And notice that when an error does happen, it prevents you from running the game, which I think is good. It makes you correct errors as soon as they're detected. So now that we have that corrected, we can press F5 to run the game. And we see this nice big magenta circle. Okay. So, more about basic class system. You can actually define events for your classes. An event is basically when some piece of code in the class gets executed. Events allow you to notify external observers that the class itself is unaware of. So it's kind of the publish subscribe pattern, if you've ever heard of that. So to add a new event, you would say circle.events and then the name of the event. Let's call it click. Let's try to make an event that happens whenever the circle gets clicked on. And equals empty table constructor. So now we actually need to write the code that triggers this event. And to do that, we'll add an update method for circle. Okay, so basically we need to check whenever the mouse gets clicked. Is down, I think it's called, right. Is down. Is there like a, let's see what else we have. Is down, is grabbed. Yeah, let's use is down. And then mouse constant. We have globals for all of these constant enumerations, so we'll actually get support for, we get IntelliSense support when we index in the mouse constant. So when the left button gets clicked, we would like to check to see if the mouse position is, its distance from the circle's center is less than the radius. So to do that, let's first compute the distance squared from the mouse position to the circle's center position. Okay, so local this2 is equal to, so we need lm dot, lm is an abbreviation for love mouse. Lm get x minus self.x, and then we need to square this. And then we also need to add the y component. Okay, so if dist squared is less than radius times radius, so if the distance squared is less than the radius squared, that means that the distance is less than the radius. That's exactly what we're trying to detect. So here's where we would trigger the click event, except that I forgot not to put self in front of radius, because radius is a data member. Okay, so now we're going to trigger the click event. And we just do that by writing self : click. We can actually give events data members, or we can give events arguments. Just give them param annotations. Let's just call this x is a number, some number. So now, if we were to call click, it would expect one argument. In fact, if we don't give it an argument, it should give us an error. But we actually, click really shouldn't take any arguments, so let's remove that. So now, let's say, now we need to subscribe to the event. So let's do that from within main. And let's subscribe to circle1's click event. We would do that by typing circle1 events click and then subscribe, and then it just expects a function with no arguments that returns nothing. So we click on the circle. It says he that tickled. Okay, so if we now run the program, let's click on the circle, and we can look at our output window, and nothing happened. And the reason nothing happened is because we forgot to call circle1 update. It's this IntelliSense thing. It's a little wonky sometimes. Okay, let's try this out. So yeah, when we click the circle, it should say he that tickled, which it does. Since it's in update, that function gets called so fast that it got triggered multiple times. If we wanted it to get triggered once, we could use the mouse pressed callback, or we could manually track when the mouse button goes up and down. The circle is too big. Let's make it 100. It's maybe 150. I mean, I want a big circle, but that's what 100 looks like. Let's go with 150. 20. That's a good size circle. Okay. So that is an event. Okay. Now let's do something exciting. Let's make the circle move. Okay, so we're going to do this using a coroutine. So I'm going to make a function that is latent. And when you make a function latent, that means that it can call other latent functions, and it can also call coroutine yield. It's good to know whether or not a function will yield, because if a function does yield, that means that you can't call it from the main thread. But even when you're in a latent function, or when you're in some thread other than the main thread, it's helpful to know whether or not a function will return immediately or whether it will yield. So I've identified functions which might yield by using this latent label. So I want to make a coroutine that controls this circle and maybe makes it move around in a square shape. So to do this, let's just create a loop, and what's going to happen is that the circle will move down and then right and then up and then left in a square shape. And we're going to need to record the initial, well, I got this backwards. We're going to need to record the initial position of the circle just so we know where the upper left corner is. Local top self.y left equals self.x. Let's see, we're also going to need a speed. Let's just make it 2. I don't know. We might have to tweak that a little bit. So, in order to move down, we are going to create a loop that while self.y is less than top plus 200. So we'll make it move down 200 pixels. Then we are going to, let's see, we have to make it move down. So we would subtract speed from self.y. And then we're also going to yield the coroutine so that we can draw the circle while it's moving down. Okay, that should work for that. You can just copy and paste this for all the other directions because they should all be similar. Okay, but when we're moving right, it's the x coordinate that needs to change. We can compare against the left rather than top. And we're also, actually we shouldn't be subtracting speed when we're moving them. We should be adding speed. Likewise, when we move right, we should be adding speed. Okay, now moving up, that involves the y coordinate. We are subtracting speed. But of course, we need to just compare against top rather than top plus 200. Okay, and we also need to call this, we need to resume this thread from somewhere. We also need to create we need to use coroutine to control the thread. So let's create a data member, let's call it T. It's probably not a very good name for a data member, but oh well. It's equal to coroutine.create, and then every class has this delegates member, and it has one entry for each method of the class. And what these members do, like they are functions that call the method on self. So so self.delegates thread. This is basically equivalent to it's equal to a function that calls self thread. So it's just an easy shorthand for writing this. Okay, so since coroutine expects a function as an argument, we just extract that from delegates rather than making a new inline ugly function. Okay, so now that we have this thread, we need to resume it. So I think update is the appropriate place to do that from. So let's see, we've got coroutine resume self.t, and let's see, resume returns a boolean, which is true if there are any errors, and returns an error message, which is non-nil if the coroutine did in fact error, and it's nil otherwise. So let's just get this error message. If sg not equals nil. So basically, when the message is not nil, an error has occurred, and we want to trigger the debugger. So you can use LÖVE debugger debug thread, and it takes the coroutine to debug as an argument, and it also takes the message. So once we're done debugging, we can just quit out of the game. You wouldn't have to quit out of the game, but that makes the most sense in this situation. So I guess we're ready to test out this circle movement code at this point. So if we press F5, well, we're already calling circle update. Yeah, I think it should work at this point. Let's see what happens when we press F5. Okay. Okay. Our circle does seem to be moving in a square shape. Great. It's almost like a game at this point, because the goal of the game is to click on the circle, and then it'll say, hee hee, that tickled in the upper window. Okay. So what happens when an error occurs in the coroutine? Let's open up circle class, and let's try to let's artificially create an error. So we can make this empty table constructor, and its type is going to be unknown. which means that we can use it in any context. And let's try to add a number to this table, because at runtime adding to tables does not make sense, but because A's type is unknown, whenever you create an empty table constructor, its type is unknown. Because A's type is unknown, we can use it anywhere. We can put A anywhere we want in the code without creating an error, or any syntactically correct place in the code, and we won't get a type error. So if we run the program right now, let's see what happens. Okay, so after this circle moved down, the debugger breaks inside this, breaks when the error occurs. So right here in the debugger, we only have access to the circles thread. The debugger works on individual threads in isolation. Let's see. If we resumed and we set a breakpoint, say right here, we would be able to debug the main thread. But let's look at some of the windows that the debugger gives us. It has this locals browser, so we've got A, that's the table that we just made and tried to add to something. Left, top, speed, these are all numbers. These are all our local variables. And self, which is the circle, of course. And note how we can expand tables and get lists of all of their fields. So it's pretty convenient to have all of this. There's also an up values window. There are no up values right now, so it's empty. I think it would be good to combine locals and up values into one window, but I haven't done that, unfortunately. There's also a globals window. The globals browser, if you have too many globals, you actually won't be able to view all of them, which is bad. But LÖVE Studio tries to prevent you from using globals in the first place, so if you're writing good code, it shouldn't be too much of an issue. Really, I should have a watch window instead of a globals window. Yeah, you can debug coroutines. If we had created an error in the main thread, the debugger would trap that error. We don't have to have any special code in order to do that. I'm just going to show that you should be able to resume out of this thread and into the main thread. So if I press F5, yeah, so now it's breaking inside the main thread. And note that in the main thread, we have 2 stack frames. You can actually browse through the various stack frames that currently exist. So like, we have LÖVE update calling circle update. And here we can see all of the local variables in LÖVE update, and we probably also have some up values as well, or at least we have one up value. And yeah, we can browse through the different frames as we wish. So let's just trap an error in the main thread just to show that it can be done. Okay. So there we go. We trapped an error in the main thread. In addition to this, we can also set breakpoints and step through code. Okay, so one minor detail about this IDE is that it has a go-to definition. You can hover over a method name, for example, and right-click it, and then click Go to Definition, and it'll open up the file containing that definition, and we'll place the caret next to it. So that's pretty helpful. And it's not just method names that you can use go to definition with. You can go to the definition of local variables and up values. So for example, if I right-clicked on the circle 1, click go to definition, it would move the caret up to the definition of circle 1. And even if circle 1 is not currently on the screen, like right now, I can still go to its definition, and it'll scroll the window to the position, to some position in which circle 1 is visible. Okay, so you can also here, let me open up circle. So here we have a type definition. We can use go to definition on type definitions as well. So if I hover over color, right click it, and click go to definition, it opens up the definition of color. Okay. Now I guess I will talk about the globals file. Okay, so we open up globals. This is kind of a special module in the LÖVE Studio IDE. So basically, if you were to try to create a global in main, or any other file for that matter, let's try to just assign some global called A equals 3. You get a red squiggly, and if we highlight this red squiggly, it says variable not in context. What this means is that at no point above that assignment we type local A is equal to some number. That's what needs to be done to put the variable in context. Well, that's one way to do it. Another way to do that is to define a global in this globals module. So, like down here, for example, we could type A equals 5. And now if we put A equals 3 in main, we should not get a red squiggly. And we don't. So that's good. So I generally think that globals are bad. It's better to carefully design your project so that references are kind of controlled. It shouldn't be the case that every object has references to every other object. And if you make everything globals, that is the case. So I think that globals should be used sparingly. But there are certain functions that are kind of universally applicable, and that might make sense to actually make global. So if you use coroutines a lot, it might be simple to add a global wait function. So let's try that. Function takes a parameter seconds. Okay. Now seconds is a number. Seconds to wait. And of course it's also latent. It's why specified number of seconds. Right. So first of all, we have to record the initial time. Is that LT? Yeah. Timer get time. And then we have to loop until the seconds, the specified number of seconds, have elapsed. So while load.timer.getTime minus t is less than seconds, do coroutine yield. Okay. And note that if we hadn't made this function latent, we would not be allowed to call yield. Okay. So now that we have this wait function, let's try using it in our circle coroutine. Let's see here. This would be in the thread. So let's say that every time the circle gets to one of its waypoints, one of the corners of the square that it's traversing, we will wait for 2 seconds. See, now we get IntelliSense for this global wait function, which is pretty nice. And also note that the call tip does have this little latent tag because it is a latent function. So that's helpful for programmers to understand that the wait function will not necessarily return right away. So let's wait 2 seconds after every waypoint. And let's test it out. 1, 1000, 2, 1000. So yeah, it seems to work. Our circle waits after it reaches a corner of the square. Okay. And it's not just functions that can be made global. You can also make global values that are not functions. Like, for example, note that right here I have created a bunch of global abbreviations for different LÖVE built-in modules. Or maybe I could make color globals. Like I might be able to say magenta equals this. Oh. Okay. And it's not letting me run because we get this error. So basically it's complaining about the alpha component of the color, and that makes sense because really if you give a record field a nullable type, the only place where you can use that as an optional field is when you're passing a table directly into a function, like we were doing with draw circle earlier. But now we're storing this color in we're storing it in a global variable, or any variable. If we stored it in a local variable, we would get the same problem. Basically, it's not sound to use a basically what we would need to have here is depth subtyping, because A right here has type number. All fields of records and all variables are non-nillable by default. And so this A really just has type number. And it says actual type, like right after actual type, that's the type of magenta. And number is a subtype of nillable number. But generally speaking, you're not allowed to use if you wanted to use a field that had a subtype of the expected fields type, that would be called depth subtyping, and you can't really do that unless the fields in both the expected type and the actual type are constant. So I believe one thing that we could do, I think if you want to make a record field constant, you'd add a tilde after the colon. And then we would also have to make the actual field constant, which we can do. I'm not sure if this is a good solution, but it should allow us to type check. Okay, so here we would just C in tab, and then this number. We need to give it a description. Yeah, so now it builds. Squiggly is still there. Oh no. Why it didn't disappear. That's bad. Okay. So that's one solution, although you might want to change alpha at runtime, or the A component. And you can't do that when it's constant. I guess another solution would be to have never made A optional in the first place. And that would allow you to change it at runtime. So this should work as well. Although, yeah, that works too. Okay. Those red squigglies are supposed to go away. I don't know what happened there. So let's see. What else do I have to talk about? Yeah, so we kind of touched on this just now. Everything is non-nil by default. So if I were to highlight A, or if I were to hover over A, it would tell me that it has type number. And one consequence of that is that I can't reassign it to nil. Actual type nil does not match expected type number. But sometimes you do want to make variables that can be reassigned to nil. And in order to do that, you just need to give them type ascriptions. You need to explicitly give the type of A, and so we can give it type Nillable number. And now it builds without a problem, or it type checks without a problem. Okay. Let's see. So we got that. Important thing to note about nillable numbers is that, or nillable variables, is that you can't necessarily access them until you figure out whether they're nil or not. So we had a function let's say a number. Now we can't just add a to 3, because if a is a number, adding a to 3 is fine. But if a is nil, then adding a to 3 is not fine. So we do get this error message. So before we do something like this, we need to figure out that a is non-nil. And to do that, you can use an if statement. If a is not equal to nil, then treat a as a number. And so yeah, that's a pretty important thing to keep in mind when using LÖVE Studio. And another thing to keep in mind is that it doesn't support the idiom of treating nillable variables as conditions in an if statement. So at runtime, this should be legal code, but I don't like the idea of putting non-Boolean conditions in if statements. So I think this error message will help you figure out what's going on. It says that a has type nillable number and it expected it to have type Boolean. So in order to create an equivalent expression of type Boolean, you just add a is not equal to nil. Okay. So another thing that should be mentioned is that LÖVE Studio also has support for generics. So in other words, you can give your objects that are made using basic class system type parameters. And so I've actually included a few generic collections as examples of this. For example, it includes a queue. So to give a class type parameters, you add this type params tag in the module header, and then just a white space separated list of type variable names. and you can comment them with descriptions. So here we have this description, the type of element stored in the queue, and if we hover over A anywhere inside the body of this module, that description will pop up. You can also do go-to definition. Not that that's very useful. So yeah, let's show how we can use a generic collection. So let's try to create a queue. Control R, queue. That should bring it into the main module. And when we instantiate the queue, we need to also instantiate the type parameter A. So local queue equals queue. And this type down here looks kind of funny, but this upside down A followed by a right side up A means that it has one type parameter which needs to be instantiated. And in order to do that, we need to give Q an ascription. So let's see. Its type is Q, but we also have to include the type instantiation. Let's just make it a queue of numbers. Okay. And now, when we say we can call all of Q's methods, but they all have number where A previously was. So in the push method, if we look at the definition of Q, the argument type is A, but we replaced A with number. So in this instance of the queue, the argument type for this instance is number. So I can push numbers onto the queue. And of course, you know, if I were to I can pop numbers off of the queue. See, pop returns a number. So yes, that is how generic collections work. Okay, I think we've come to a pretty good stopping point. Thank you for watching this video. The end.